Let's talk about the conversion between base and derived classes. So here we have a text box. Now, because every text box is a kind of widget, here we can declare a variable of type widget and assign it a text box. So our text box gets implicitly converted to the widget. Now, this is called upcasting because the conversion is upward towards the base class. Now, the opposite of upcasting is downcasting, and it's illegal. So if we have a widget, we cannot declare a text box and assign it the widget, because in this text box, we have some additional members that don't exist in the widget. For example, in our text box class, we have these additional members that don't exist in a widget object. So when we write this line of code, the compiler doesn't know how to convert a widget to a text box. It doesn't know how to add those additional members to this text box. So this is downcasting and is illegal. So technically, you don't ever need to do this unless there is a problem with your design. So let's go back to upcasting. So we have a text box, and we can declare a variable of type widget and assign it a text box. Now, upcasting also happens when we pass this text box object to a function that has a widget parameter. For example, let's define a function called showWidget that takes a widget. Now, if we call this function and pass our text box, again, upcasting happens. So we call showWidget and pass a text box. So again, the text box gets implicitly converted to its base type, widget. Now here we have a little warning saying slicing object from type text box to widget discards 24 bytes of state. What is happening here? Well, because we're passing this object by value, we are not using a reference, this object has to be copied into this target parameter, right? Now, as part of this copy operation, the compiler has to discard the stuff that we have in the text box that don't exist in the widget. More precisely, that is the value attribute. So the size of a string object by default is 24 bytes, and that means when we pass this text box object to the showWidget function, the compiler has to discard 24 bytes of data. This is called object slicing. Now, object slicing doesn't happen if we use a reference or a pointer. For example, if we use a reference parameter here, the warning goes away because no copy is done. So we're passing a reference to an actual text box here. However, even though we're passing a text box object here, we don't have access to any members of the text box. So here we cannot call getValue or setValue. We only see the members of the widget class, okay? Now we have the same scenario if we had a pointer here. So if we change the type to widget pointer, like here we have to use the address of operator. Again, no slicing happens, and in this function, we only have access to members of the widget class.